So in starting our course, I would like you to review some of the review sections in the beginning part of the book. In particular, I would like you to look at section R2, which is on pages 17 through 24. These pages are necessary to some extent to review some of the things learned in Math 1310. In this particular section, we're going to use the distributive property, and that's going to be important for us throughout this chapter. Factoring expressions, we're going to be doing a lot of factoring, finding the least common denominator for rational equations, and solving a variable in a linear equation and solving a variable in a rational equation. So those are the things that the skills you will need for chapter 1. So let's first talk about the distributive property. So to do the distributive property, I have example number 1, where I have a number in front of parentheses of a two-term expression, where I have 3 parentheses x minus 4. To use the distributive property, I multiply through the two terms. In other words, I have 3 times x minus 3 times 4, which is 12. So I have 3x minus 12. So that is the use of the distributive property. We're going to now expand that idea of the distributive property to something called FOIL, which is first, inner, outer, last. And here the distributive property, I use the first term in the first set of expressions times the first term in the second set of expressions, and then I use the first term times the last term in the last expression, and so forth. As you can see, the arrows are showing you how I'm distributing. So when I start out, I have x times x, which is x squared. Then x times a plus 1 is a plus x. Then a minus 3 times x is equal to a minus 3x. Then a minus 3 times a positive 1 is a minus 3. Now, we're going to use the term combine like terms. A lot of times you will see me use the expression CLT, combine like terms. So in this case, the two terms that are like each other are the x terms, so I can add the coefficients, and in this case I get x squared minus 2x minus 3. Now I would like you to pause. You will see, I want you to try actually. Now try expanding parentheses y minus 3 times y plus 2. Pause the video right now and try that, and I will show you the answer in just a second. So in this case, you should have gotten the following answer: y squared minus y minus 6. In this chapter, we're going to be doing things called factoring. Suppose I have the following equation: 4x plus 6. Now to factor this expression, I will take a 4 out of each term. So by taking a 4 out of each term and putting it in parentheses form, I see I can put a 4 in, and then obviously the parentheses is x plus 4. Now if I have a 3-term expression where the factor, the first term has a square in it, and if I have a square term in there, the chances are that I have an expression that is factorable into two pieces. In other words, I have an x in one piece and an x in the other piece with parentheses. So to factor this, I look at the last term of the 3 term, and I notice it's 21, and 21 has 2 factors to it, 7 and 3. And then I come over here and I note that a minus 7 plus 3 is equal to a minus 4. This minus 4 is my middle term in the 3-term expression. So now I can exchange this to this factor, where I have parentheses x plus 3 times parentheses x minus 7, and that is factoring the 3-term quadratic that I have. Now, again, I'd like you to try to factor x squared plus 10x plus 9. I would like you to pause the video, try that on your own, and in a few seconds or minutes I will give you the answer. Well, you should have obtained the following factors: x plus 9 times x plus 1. All right. Our next sort of skill is finding the least common denominator for a rational expression and simplifying. So we're going to simplify the following rational expression. In number 1, I have just fractions. 2/5 plus 1/6 minus 1/3. You will notice that the LCD, the least common denominator for the denominator, is 30. It's 5 times 6. So when we have an expression, we have to adjust each fraction to the least common denominator. This means that 2/5 now becomes 12/30. Why? Because I have to multiply both the top and the bottom by 6. In the second fraction, or the second term, I multiply both the top and the bottom by 5 to get 30 on the bottom. And in the last fraction, I multiply both the top and the bottom by 10 to get a minus 10/30. Now I just add the numerators across, and you can see that I get 7/30. So that is my answer for the simplification for the first expression. The second expression now has variables in it, and so now I must have a different approach to the least common denominator. Here, the factors of the least common denominator are x plus 1 and x minus 2. Here again, I have to adjust each fraction to the least common denominator because it is just an expression. So you will notice that the first term now becomes x minus 2 over x plus 1 times x minus 2. See, I multiply both the top and the bottom by x minus 2. The second term becomes 2 times x plus 1 divided by x plus 1 times x minus 2. And now when I do the simplification, the numerators now combine. I have this as my numerator, x minus 2 plus 2x plus 2 over x plus 1 times x minus 2. And now if I combine like terms, I just end up with 3x over x plus 1 times x minus 2. Now again, I would like you to try the following expression, rational expression, 2 over x minus 3 minus 5 over x plus 7. Please please pause your video and I will give you the answer in just a few seconds. So in this particular case, you should have gotten the following. You should have gotten a minus 3x plus 29 all over x minus 3 x plus 7. Okay, so our last topic we will get to in just a second. So now we're going to solve for a variable in an equation. So in step number 1, there are two ways to approach the problem. For the problem 2 times x minus 6 parentheses is equal to 24. I could either divide both sides of the equation by 2 and I end up with x minus 6 is equal to 12, and then when I add 6 to both sides I end up with x minus 18. Or I could actually distribute the 2, and when I do that I get 2x minus 12 is equal to 24. I add 12 to both sides of the equation. I get 2x is equal to 36, and I divide 2 by both sides and I again get x is equal to 18. So both approaches work in this particular case. Now when I have a rational equation, the first thing I must do is find the least common denominator. Well, in this case, the least common denominator of the three terms is x minus 2, x plus 1. You will notice that this is not an expression, so I will not adjust each fraction to the least common denominator. I will multiply the least common denominator to both sides of the equation. In doing that, I eliminate the fractions. So when I take the x minus 2 and I multiply it by the term 1 over x minus 2, I just end up with x plus 1. When I multiply x minus 2 times x plus 1 times 3 over x plus 1, the x plus 1's cancel, and I'm left with 3 times x minus 2. On the other side of the equation, I notice that the x plus 1's cancel, and I'm left with 5x minus 2. So here's the equation from multiplying through by the least common denominator. And if I go through the process of combining like terms on both sides of the equation, I get 4x minus 5 is equal to 5x minus 10. And of course, I can reduce this down to 5 is equal to x. I want to make sure that in fact the solution works, so if I put it back in, I have to make sure it works. It does in this case. The other thing I have to worry about is to make sure that I don't have 0 in the denominator. So if the 5 caused it to have a 0 in one of the denominators, that would be a no solution situation. So in this case, the numbers that could not work would be 2 and minus 1. Well, that concludes our skills. We're going to be talking about all these skills in section 1, so we'll be going to that first.